Hello everyone. Am I visible? Okay. So hello everyone. This is Professor Pankaj Biswas. Now I am live to discuss about your queries about the course entitled Fundamental of Welding Science and Technology. You are all very well familiar about this course. Already I think 4 weeks is over. So you are very well familiar about this course. In this course, you know that I have discussed about fundamental knowledge related to welding. So in fundamental knowledge related to welding, in the sense here I discussed from the very basics things initially, that is what is welding, what are the different classification of welding, depending upon the different aspects, how the welding is classified, that related things I have discussed in details. I discuss in detail about what it's called history of welding. Then I discuss about what are the different history of power source of welding. Then I discuss about categories of different types of power source. Then I discuss also about what is called physics and principle involved in welding technology. So these related things already I have discussed. Some of you ask me some question related to these topics or whichever you have covered in this course. So first of all, I'll discuss about those queries. After that, if you have any live queries now also, that thing related also I will discuss in this live session. So, so first question, actually, I'm just checking one by one, and I'll just discuss about all these things. 1 minute. So one of the question, which is asked by what's its name? Kundan theory, actually. So Kundan theory, thank you so much for your queries. You ask a question, what are the best courses to attend for being a highly paid welding engineer? Yeah, that's a very interesting question. That Kundan, thank you so much for your queries. You know that whatever the things actually we are covering in this course, that is actually very much essential to be a highly paid welding engineer, that you can say. Because in this course, I try to cover the basic fundamental things, which is generally we have to know related to welding once you will be in a manufacturing industry. Because once you will be in manufacturing industry, there we will see generally there are a lot of problem arise due to welding. Because you see, in welding industry or in any manufacturing industry, you can see there is a separate you can say separate team are there, which generally observe the quality of manufacturing product. What they means what it's called observe there, they generally, that is called quality control division, you can say. So that quality control division generally check whether your manufacturing product is good or bad. In this manufacturing product, generally what they observe the main things, that is called how it is manufactured. First of all, if there is any welding, they primarily check in welding region whether there is any defect or not, frankly speaking. So to get a good welding, you should have idea about the fundamental knowledge of welding, first of all. So that's why these fundamental things I try to cover in this course. After that, you will find actually what are the different quality generally required in a welded joint. These related things also I discuss detailed in this course, because in this course I try to means structure in such a way so that you will get a overall fundamental picture of welding technology. Okay, so overall fundamental aspects of welding technology, what does it means? Means here you will find from the sketch, actual sketch, what is welding, what are the different categories of welding, what are the physics, mathematics, engineering, or you can say principle, what are the different things generally required to know about welding in details. That related thing I discussed here. Then I discuss here the very basic types of welding technology which are widely used in manufacturing industry, generally whose application is more in most of the manufacturing industry. That related things in details I discuss in this course. I discuss in details about the different testing, that means the destructive and non-destructive testing methodology in details I have discussed, how these different testings performed, so that you will get after generally a 7th, 8th week. In 7th and 8th week you will get all these things. After that I will discuss also about the different types of defect which is arise in welding and how we can eliminate or how we can mitigate, or you can say how we can reduce that defect. So that related things in details actually I covered in this course. So this is such a course, here you will get most of the fundamental things in details, frankly speaking, which is required to be a highly paid welding engineer. But here you ask me what are the best courses to attend for being a highly paid welding engineer. So here I want to say something related to what are the different types of highly paid means welding engineer salaries are there. That's related things I want to say first. Generally, you can't imagine a welding engineer can earn yearly around 60 lakhs maximum. That means it's varying from 30 lakh to highly paid. Actually, I'm just telling highly paid welding engineer. So in foreign country, it's varying from 30 lakh to 60 lakhs. Whereas in India also, a highly paid welding engineer can get 10 lakh to 30 lakhs per annum. What I'm telling, understand? That's why there are different types of training schools are there. So if you are interested to get some well certified course, all over world you can say these certified courses are available. Like here, just I am on to give some name of that means welding institute, where once you do the course, then you can get lot of exposure. Lot of exposure in the sense, what are those exposure? That related thing little bit I will discuss now. Like here, some courses are there. Just 1 minute, I'm just showing those. Yes. Some of the welding institutes name I am just telling here. Like you see, one of the very best welding, you can say, welding certified program, which is organized by Hobart Institute of Welding Technology. Okay, but what happens? It's a highly means high cost types of course, because here this course generally 24-week course. This Hobart Institute of Welding Technology. Its cost is around $11,700. Can you imagine? $11,700, because it's a very costly types of course. This is a welding certified course. Here generally you will get structural welding, structure and pipe welding related things. There are a lot of other courses are there. Like you see, you will get Tusla welding schools. There also, it's also very costly types of program. There are some other means they generally provide you some certificate. So once you have certificate on this types of schools course, then what happens? Definitely your CV and other things will be, and you will be generally more paid one in industry. What I'm telling, understand? Similarly, Elite Welding Academy are there. Then Advanced Welding Institute, also American Welding Society. So there are a lot of different types of welding schools who generally organize welding certification programs. What I'm telling, understand? So once you'll go through the nets for different types of welding certification program, you will get different nomenclature. But among these, whatever the names I told right now, that means Hobart Institute of Welding Technology, then Davis Technical College, then Elite Welding Academy, then American Welding Society, Advanced Welding Institute. These are all the very prestigious certified course. If you will generally get the idea from this different course, any of these different course, then what happens, definitely you will get a very prestigious types of salaried package in welding company. What I'm telling, understand? But thing is, before going to means these types of program, I think first and foremost thing required is you should have fundamental knowledge on welding. So that fundamental knowledge which is required to attend any types of advanced program is available, what I feel, in this course, because this course is fully start from the scratch, you can say, because here I discuss very basic things to very tough things. What I'm telling, understand, means how it's start from start to end types of things I try to cover in this course, because here how it is started and how that means completed means what are the defects generally arise, what are the testing required to control the quality or to check the quality of manufactured product which is manufactured by welding. That related things in details I have discussed in this course. What I'm telling, understand? So definitely this course will be very much helpful, because what happens, whatever the things I try to cover in this course, most of the things is really related to industry oriented, and this course also related to, you can say, related to the question, whatever the question generally asked in most of the manufacturing industry, that related things I try to cover in this course. So if you'll go through this course, you will be definitely a fundamental one in welding field. So after that, you can do different whatever the different school name I told. If you can gather some highly prestigious welding program certificates, definitely that will be very much beneficial for you to get a higher salaried one. What I'm telling, understand? That is the future scopes, you can say. What I'm telling. Yeah, definitely. Some other courses on welding also there. This is the fundamental course. Some other welding course also are there. Like I have another course that is called Welding Application Technology. In this Welding Application Technology, you will find it is already last year already it is started. So there I also covered the little bit advanced thing than this one. There also I covered most of the fundamental things, but that course is related to more on research oriented. What I'm telling you, that course is related to more in research oriented actually. Okay, so there I try to cover what it's called, what are the drawbacks in welding. That means how the due to welding, what are the things arise. In this course also at the beginning, I told you people that, okay, welding is such a techniques in which you observe that intentionally we are creating defect in structure. Correct? Because once you do the welding, there the structural integrity change, because due to fusion welding, its material melt. Once material melts, then melting related lot of defect arise in welding welded product. Okay, so intentionally we are creating this defect in structure, but that things we can't avoid, because nowadays without welding, you can say manufacturing industry is not possible. That you can say, but you see, intentionally we are creating that defect. That now this defect, due to this different defect, what are its adverse effect? How we can control this defect, how we can minimize this defect, how we can measure this defect, everything in details. That thing generally I discuss in my second course in details. Okay, that is related to research oriented actually, research or industrial oriented. There are also fundamental things are there, like there I covered most basically the what it's called welding induced distortion, welding induced residual stresses, then different types of other advanced welding techniques which have a very high application in very high quality industry. What I'm telling, understand? That means in advanced industry. So that related thing I discuss about details and that in that course. Apart from these things, how to design a welded structure, that related things also I discuss in that course. So once you go through that course, then I think what happens here, this once you follow these two course, you will be very well fundamentals in welding. Definitely, others lot of different courses are available. You can go through other courses also. But what happens thing is for fundamental things for a beginner, this two courses is more than enough, what I feel. Okay. But here one thing you should keep it away. High paid welder can have a salary around 60 lakh per annum. What I'm telling, understand? That is, generally diverse welders who generally dive in ocean and do the welding operation. Their salary, you can say that is very high. Their salary per annum is around 60 lakh to 1 crore like this. What I'm telling, understand? So therefore, training of those types of things, there are different types of training schools are available. In IIT Guwahati also, we are trying to opening a school. You will get that schools actually. I am one of the co-PI, you can say, of that training school. Here we also try to open a school on welding, underwater welding and maintenance training school. Okay, so in IIT Guwahati, within 3-4 months, we are means opening this school. In this school, you will get certificate, you will get hands-on training, you will get different types of course material. So it's a well equipped school, you can say. This school is generally train train the student, or you can say train the employee of different industry how to do underwater welding and how to dive underwater and do the welding and maintenance of different types of welded structure. Okay, that related things actually we're going to open very soon, and it will be operating, you can say, condition within 4-5 months. So I am also involved in this school. So if you are interested, you are always welcome. You will get the advertisement and all the things related to this course. So that's how you see, once as you ask, highly paid welding job. You can't imagine if you have a very good fundamental in welding, your salary can be very high. What I'm telling, understand? Now another question asked by what it's called. 1 minute. Yes. Where is that question? Yes. Another question asked by one of your friends who asked me that I am a student of third year mechanical department. His name is Horin Bhattacharjee. Okay. He asked me, and I would like to ask the current innovation in the welding field. He asked me a question, what is the current innovation in the welding field? And he also mentioned here what industry 4.0 means to the welding department. Yeah, it's a very good question. Nowadays, this industry 4, it's a very popular name, because you see this generally industry 4 means here due to the development of IoT, Internet of Thinking, automation, and all the things. Nowadays, generally, most of the industry is try to be registered in the form of industry 4. What I'm telling, understand? Industry 4 is a very latest you see innovation, or you can say latest development in industrial field. It try to means you see connect all the automation field in industry. What I'm telling, that is very well familiar to you. Now you are telling actually how this industry 4 means to the welding department? This is a very good question. Definitely in welding department also you will find there are a lot of scope to develop industry 4 oriented welding department. Here also we can automate the thing. Here you can automatically control the process parameter, because already there are a lot of automation in welding industry are there. Now this welding industry automation things also can be in wave form. Wave form means Internet of Thinking. That means some things here we can develop. This thing we can transfer to an industry. That industry can automatically, or that means from here itself we can share our data to industry. That data can be utilized in industry. So also there can be lot of automation. That means from here itself we can automate the process. That related, already there are a lot of automation available in industry, and there are a lot of web-based information also available in what it's called welding department. There are a lot of quality control oriented automation in welding industry are available already. So whatever the thing related to this automation, then connectivity in different field and web oriented, that things you can consider in the form of industry 4. That is very well familiar to you people nowadays, because so I am not going in detail, because this course is just give you the fundamental knowledge on welding. This course is not related to industrial these things. But from here also you can get idea where how the automation can be done, because nowadays you will find there are a lot of automatic things, like because this welding technology are using in 3D printing technology. This welding technology is machineries. So these are all generally, so this 3D printing things is fully related to industry 4 oriented. So once welding technology is used in 3D printing purpose, then it's also a, you can say also it more or less similar types of industry 4 welding department. What I'm telling, understand? So yeah, once you go through the net in details, you will find what are the means industry 4.0 means to in welding department. In details you will get, but little bit brief idea I have provided you. So at least you will get the idea actually what does it means. Okay. Now Ranjit Rajput, who asked me a question, I want to know about welding electrode. Ranjit, actually in this course I have provided the welding electrode in details, specially based on welding electrode composition, how the welding is categorized. Here I have not provided you the knowledge about what it's called, what are the different types of welding electrode based on different countries standard. Like what happens, you can Indian standard welding electrode are there, American standard welding electrode are there, ISO electrode are there. So that related information I have not provided here, because that's that related things I try to provide in another course. Okay, that is different things. But here whatever the electrode related things I have provided, that is I have provided in SMAW welding technology. There I have told you about welding electrode, which is classified depending upon its composition. So I have already told you this electrode can be cellulosic types of electrode. That means where the main composition is cellulose. Then the electrode can be basic types of electrode. This electrode can be rutile types of electrode, and this electrode can be what is called metallic powder types of electrode. So this depending upon this means flux cover of the electrode, generally this electrode related things, and what are the flux cover composition, that related things classification I have provided in this course. But if you want to know more about electrode, depending upon means American Welding Society, Indian Welding Society, then ISO Society, British Standard, for that actually that there is required some other course. What I'm telling you, that related thing I have not provided. But whatever the things I have provided on this general, this based on this composition based on this composition only, you will see some standard use some more types of what is called oxide, some standard use some other types of precaution, this thing, that thing. So that related things generally I have not provided in details here, but basic things I have provided here. Apart from these things, here you see I have already discussed about other electrode also. Bare electrode in the sense in what it is, GMAW process, gas metal arc welding process. Generally, they are not using what it's called flux cover. They use bare electrode. That means which is not covered with flux, correct? So that is a bare electrode. That electrode composition generally is very well compatible. That electrode composition should be well compatible with parent material. That's why what happens, that electrode generally have a standard. That is a common standard. So that related things also I have discussed in this course. Okay, so you will find information once you'll go through this SMAW welding process and GMAW welding process in details. You will get the information about the basics of electrode. But if you want to know further different standard, that means ISO, American standard, then Indian standard, then what it's called British standard, different, what are the nomenclature of those electrode, what are the characteristics of those electrode, you have to go through some other course, what I'm telling, understand? Okay, thank you. Now if you have any queries, you can ask me question now also. One more question asked by, let's see, there is one question in 1 minute. What is that question? Yes, 1 minute. Yes, I am checking actually one by one. Shanjit, metallurgy. Sir, please explain various modes of metal transfer in fusion welding. Shanjit, actually, thank you so much for your questions. I have already discussed in details actually about the metal transfer, mode of metal transfer in fusion welding process. There I have explained what are the different types of what it's called metal transfer generally occurs. There I have discussed about, there are mainly what it's called two different categories of, mainly you can say, though I have shown different classification, but mainly two different classification of metal transfer are there. One is called what it's called free flight transfer. Another one is called short circuiting types of metal transfer. In short circuiting types of metal transfer, I have discussed in details generally during this metal transfer, short circuiting metal transfer. There generally what happens, there occurs direct contact between electrode molten pool with electrode and what it's called base material during transfer of material from electrode to workpiece. So at that time, generally during metal transfer, what happens, there occurs some short circuiting. So short circuiting, once it's occur, then your arc will extinguish. So what happens due to this? So here in short circuiting types of metal transfer, there occurs some arc extinguishing types of phenomena that I have discussed in details in this course. You just go through my lecture, you will find everything in details. In free flight metal transfer, I have shown what are the different types of free flight metal transfer are there. There are globular types of metal transfer, there are jet types of metal transfer, there are what it's called spray types of metal transfer. Then in spray types of metal transfer, I have shown there are different categories of spray metal transfer, depending upon the size of this molten droplet. Correct. So in spray types of metal transfer, generally I have already discussed over there. Generally, its diameter is equal to or less than the diameter of the electrode. That means its molten droplet diameter is equal to or less than the diameter of the electrode. Whereas in globular types of metal transfer, its diameter is around more than this diameter of the electrode. Now you see how this metal transfer droplet is reduced. That related things also I have discussed in details. Generally, you observe there, generally welding current have a significant effect in metal transfer, especially in case of consumable types of electrode. It's especially in case of what it's called MIG welding process. So there I have told you that means welding current generally is mainly responsible for what it's called that droplet detachment purpose, because this welding current generally develop the what it's called Lorentz force. That means it's this Lorentz force, how it is, that things also I have explained in this course in details. Lorentz force is generally developed due to this self-induced electromagnetic field. What I understand, because once there is a flow of current, then perpendicular to the flow of current there is occur a what it called electromagnetic force or electromagnetic field. That electromagnetic field generally creates some what is called pinching effect as well as radial effect. That means radial effect as well as transverse effect. So this radial effect generally helps to form the necking in case of drop transfer. So what happens if this pinching force is more? Then what happens? You see, always keep this thing. If this pinching force is more, then your chances of neck formation will be more rapid. What I'm telling, understand? So what happens once the more rapid neck formation will be there, more will be the drop transfer. So that's why I have already told you, that means this electromagnetic force generally which is developed, or pinch force which is developed, or that is called generally Lorentz force, because a researcher whose name is Lorentz who first identified this force. That's why it's based on his name. This force is also termed as Lorentz force. So this Lorentz force generally it is observed that it's proportional to a square of the current flow through the electrode. That means around a square of proportional to the square of current flow through the electrode. So you see, here the current, here will be this necking force. So you see, so to get more and more smaller types of droplet size, our current should be higher side. And what happens due to this higher current, there also develops some high what is called high flow of electron. Due to this high velocity electron, generally this droplet velocity and droplet impinging force, you can say, also increase. Due to this high current, so droplet size as well as increase, as well as its penetration of this droplet to the base material also increase. These things, that things related things and details I have discussed. So here I am just discussing about the current only. Apart from current, there are a lot of other parameters are there which affect the drop transfer significantly. So in details I have discussed over there, Sandeep. You just go through these things. If you have particular types of other types of question in your mind, you can always call me. I have already give my office contact details. Apart from these things, if you want my phone numbers, you can mail me in my office email ID. I will definitely provide you this my contact numbers. Personally also you can discuss, you can ask if you have any queries related to this thing. Okay. And Shundeep, you have asked another questions also, that okay, sir, what is the significance of duty cycle? Yeah, Sanjeev, duty cycle, actually you are very well familiar that what is duty cycle. Duty cycle means arcing time divided by what total welding time, means what is called welding time divided by arcing time. That things actually I have explained. That means arcing time is equal duty cycle equal to your welding time divided by arcing time. Now generally a depending upon this duty cycle, you should use your, or you should utilize your welding time, because if you use more time than this than following this duty cycle, then what happens, your means welding machine can damage. That's why I have already mentioned over there, you should strictly follow this template or the manual which is provided which is generally provided during purchasing of a welding machine. So in this manual or what it's called template, there is provided what is the means duty cycle of this welding machine. That means how much maximum current you can use, how much maximum time out of 10 minutes or out of 5 minutes, depending upon, according to American standards, we use generally 10-minute time standard. European standard generally we use 5-minute time standard. So according to that things, how out of this 10 minutes, how much time you should weld. What I am telling, understand? That means total let's arcing time is 10 minutes. Out of this 10-minute welding machine operation, okay, how much time you should weld? What I am telling, understand? If you use more time than that one, following this duty cycle, then there is a chance of damaging of that welding machine or damaging of this wire cable or damaging anything. What I am telling, understand? That's why welding, these things have a, this duty cycle have a significant effect in the weld machine safety. What I am telling, understand? What is the factor affect the melting rate of electrode during welding? Sanjit, actually I have already told you, generally melting rate is dependent on what? Heat. So heat is proportional to what? Voltage into current. So you see, so higher will be the heat, higher will be the melting. Correct? So melting rate, what does it means? Melting rate means per unit times how much material is melting. Now you see, if your this V into I, that means voltage into current, is your welding power, you can say welding power. So voltage into current, if this is actually in watt, its unit is watt. Okay, now to convert these things into joule, generally what are the things required to you can divide it, these things by what, you can multiply this thing with time. Okay, that is called generally heat input. Okay, so you can say V into I is welding power. So higher the welding power, higher will be the heat, higher will be the heat, higher will be the melting. So you see, so higher will be this what is called current or voltage, your heat input will be more, your melting rate will be more. That's all. This is a very simple things. I have already explained in this course in detail. Okay, now here you see, apart from this thing, there is a terms, another terms also used, that is called generally welding velocity. So welding velocity also have some effect in what it's called welding melting rate. That related things also I have provided in this course. You just go through little bit in details, you will get. But main things, the melting rate is dependent on heat input. That's all. Higher the heat input, higher will be the melting. That is very straightforward thing. Okay. But you see, to get a desired weld quality and other things, we cannot just increase our welding current or welding voltage significantly, because what happens, for a particular types of quality, for a particular types of qualitative product, generally we should follow some it means optimum data, optimum process parameter. So that's why what happens, you can see in this course also I have shown actually how to optimize the welding power, because there I have shown that okay, this optimum power dependent on what it's called arc length also. So there also I have discussed what should be the optimum arc length for the particular welding voltage and current. For a particular arc length, what should be the optimum power you should use. So that related things in details I have discussed. That is very, that related means question generally arised in different types of competitive exam. Like there I once I discussed about this arc structure, correct? There in this arc structure, there I have shown that voltage V is dependent on, or what is called A plus B into L. What is A? A is the generally what is called cathode and anode spot voltage drop, and B into L, this is generally voltage drop in arc column region. Okay, so depend upon these things, generally voltage characteristics in details I discussed over there. Just you go through little bit that topics, you will get everything in details. What should be the optimum power in welding to get a optimum arc length, to get a optimum power output, or optimum quality types of weld. That related thing in I discuss in details here. Okay, you go through little bit on this, you will get everything in details. You have completed that lecture. I think you got now, and I think now you got the idea about this thing. Okay, the course video of fourth week are available only from today. It is too late. Okay, I will definitely talk with the organizing committee, and I will talk with my TA about this thing. We will try to provide you all the course material as soon as possible. Okay. Guru Prasad Rao is assignment 2. The question number 13, the flare bevel group symbol. Correct answer choice is not given. Okay, we will provide you, Guru Prasad. We will provide you the correct answer definitely. Okay, I'll discuss with my TA, and definitely we'll give you, if it is wrongly put it, we will correct it and we will provide you the marks. Okay. Anurag Singh, minimum cost welding. Anurag, actually, you asked me what is the minimum cost of welding. Minimum cost of welding, you can't imagine. Actually, a welding machine, what you want to ask, actually, I'm not getting. Actually, Anurag, if you can ask again, minimum cost welding means? Okay, oh, you want to know actually which welding cost is minimum. You see, generally minimum cost welding, that way if you can think. So yeah, generally that is called SMAW welding is generally cheaper than other welding process. SMAW as well as oxyacetylene gas welding. These are the welding process which are generally very cheap one, and which are generally very easily available one. In roadside at night time, some spark you observe. That spark, generally what types of welding that welding is generally SMAW welding, shielded manual metal arc welding process. So these are the generally cheap welding process, but again cheap, that way you can say, actually generally cheap in the sense what types of material you are using. If the material is very cheap material, there the electrode will be cheaper type, cheaper quality, so then your welding cost will be less. So depending upon your type of joint, quality of joint, generally this cost and other things is coming. Okay, but generally cheap welding process is, you can say, SMAW, then gas metal arc welding, because after that generally lot of other different advanced types of welding process means are coming. Okay. P. Sunil Kumar, sir, can you explain brief welding characteristics? Yeah. Sunil, actually, okay, I will ask. I'll just discuss little bit about welding characteristics. Actually, there you can observe in welding characteristic I have shown. The welding characteristics generally can be a little bit, I am telling here, can be two different categories. One is called constant current power source characteristics. Another one is called constant voltage power source characteristics. Apart from these things, combining of this constant current and constant voltage one, we categorize another welding characteristic power source characteristic, that is called combined characteristics power source. Correct. So in constant current characteristics power source, which is generally why it is called constant current characteristics power source, CC power source, because here in this power source, generally if there is a means last fluctuation, that means if generally last fluctuation, then also you can see, yeah, they are generally your what it's called current changes comparatively less. That means almost constant current is there due to high change of arc length, you can say. So high change of arc length, a small change of current is there. That means almost current is constant here. That's why what happens, these types of characteristics power source is called constant current characteristic power source. Okay. Another characteristic that is called constant voltage one, where there is a small change of arc length, there is a large change of current is occur. What does it means? So there I have explained in details. If you can go through this constant current and constant voltage power source, let's see if okay, actually there are some other question, otherwise I could have explained this thing by drawing the things. So in constant current power source, you observe as there is a less change of current due to fluctuation of arc length. That's why this constant current power source characteristics generally preferable in manual welding purpose, because in manual welding purpose there is a chance of shaking of hand and other thing, there is a chance of fluctuation of the arc length is more. So that's why, though the fluctuation of arc length is more, but there is a less chance of variation of this current. That's why it does not affect mass and weld quality. What I'm telling, understand? That's why I have shown there that the characteristic curve is drooping in nature. Okay. Another one is called flat characteristics, or that is called constant voltage characteristic curve. So that is generally preferable in automatic types of welding purpose, where if the automatic types of wire generally fluctuation and other things is comparatively less. But if there is a small fluctuation due in automatic welding process, if there is a small fluctuation is there, then what happens? Its current is increased drastically. What I'm telling, understand? Mass current, that means here the current is increased more. So due to this high current increment, what happens? Here the melting rate and other things increase. Okay, melting rate and other thing increase. So what happens? It's due to this melting rate increase. Why this melting rate increase? Because here the drastic change of current occur. That means more current change. A small change of arc length, here more current change, or a small change of voltage, more current changes occur. So more the current change, more will be the melting. So it adjusted, means it adjusts the arc length again generally. So here the arc length remained almost constant due to this what it's called readjustment. So that's why this is called self-regulation characteristics of arc. So what happens here? A small change of arc length, automatically current increase. So what happens? Your burning rate increase. So it's resize its arc length means very quickly. So that's why what happens? These types of things is occur in what it's called automatic types of welding operation. Another one is there, that is called combined characteristic power. So that related things also I have discussed over there. Apart from these things, I have also discussed about what is called dynamic characteristics power source. There I have shown there is a curve that is called generally what is called in dynamic characteristics power source. There I have used generally a peak current and what it's called background current. Okay, so depending upon this peak current and background current, in dynamic characteristics curve you can generally that is also called pulse mode characteristics power source. That means some pulses we are using. So one pulse is peak current, another pulse is background current. Okay, so this peak current generally responsible for melting the electrode, and background current is responsible for arc remain ignited. That means arc remain ignited state. This is a DC types of characteristic. That means all are generally this constant current, constant voltage. So this here generally arc remain ignited throughout the entire welding process. That means in pulse mode power source. So once you go through my lectures, you will get in details about all these characteristics. Okay, but thing is, these are the different characteristics. One is especially used for manual welding, one is for automatic welding purpose, one is generally used for very controlled types of welding operation. So once you go through these different types of power source characteristics, you will get the detailed idea about this thing, how it is varying, how it's affect the weld quality, drop transfer, and all the things. So everything details you will get. Okay. Shanil, okay. Then Rajesh Kumar, good evening, sir. Kindly explain about selection of welding electrode. Okay. Rajesh, actually, as time is only 5 minutes remain, so Rajesh, another two, three questions. Selection of welding electrode, I have already discussed in SMAW welding process in detail by. So how the what types of electrode should use for what types of material and why, that related things in details I have discussed, and more details you will get actually as this is fourth week. So after that only you will get everything in details. Okay, because in SMAW welding process, then GMAW welding process, then submerged arc welding process. So all this welding process, whatever the electrode, whatever the flux, whatever the means things that we generally use, that related thing in details I have discussed. So you will get everything in details. Like in SMAW, you will find cellulosic types of electrode. Where is the application of cellulosic types of electrode? What is the characteristic? What is the advantage, drawback? Everything in details I discuss in this course. Then what is the rutile types of electrode? What is basic electrode? Where is the application of these different types of electrode? Everything in details I discuss. So you will get everything in details over there. You need not to worry about these things. You just go through my course. I think you will find your answer. Okay. Guru Prasad. Arc length voltage characteristic numerical problem solution for the fourth question is assignment 3. Please explain, sir. Guru Prasad, actually, I will actually, it will be better. Actually, I will send you the solution in details. Okay, because the time is not there, right? Okay. So otherwise, you can send me a mail. I will just reply the solution of this assignment 3. Okay, because now if I'll go to explain the solution of this assignment 3's problem, it will take another 15 minutes. So time will not permit. Okay. Garvin. Chanjit Metallurgy, thank you, sir. Anurag Singh explained perfect welding bit. Anurag, this explaining of perfect weld bit, just here one thing you should know. Generally, this welding defect, once you will study, there you will find actually, there I explain nicely what weld bit is perfect, which weld bit should be perfect. So there is some specific ratio between weld bit width versus depth of welding. There is a transition angle which we use generally in case of weld bit. So depending upon this transition angle, like this transition angle should be more than 135 degree. What I'm telling, understand? Similarly, what it's called this weld bit, generally bit width to bit depth ratio should not be more than 2, or should not what you call less than half, something some very interesting. That means weld bit depth to weld bit width, this should not be more than half, or if you think about weld bit width by weld depth, it should not be more than 2, something, some very interesting types of points I mentioned over there, that is in welding defects and its inspection in details. There you will find what is a good weld bit. But here there you will find there is some transition angle we use in weld bit, because the weld bit, if you will see, there you will see there is a convex types of contour is there. So in convex contour with horizontal plane, if you take a tangent at the end of 2, there we will there will find a angle between this tangent and this horizontal surface. This angle should not be less than what is 135 degree. This is on criteria to get a good weld bit. So that thing I have explained over there. Then let's you have some weld bit width and weld bit depth. So this well bit width to well bit depth, there is also some criteria. It should not be more than that ratio. This ratio should not be more than this, less than this. Something we have explained in details over there. You will get a detailed idea over there. Okay, right? That is that thing's not yet completed. You have not yet completed. Yes, sir. Uma, sir, can we weld naval steel using FSW? Yeah, and pulse ticked MIG welding process. Yes, we can do, because in naval steel generally here itself we worked on a naval project that is called general. There we use this naval steel. That is DA is 36, AA is 36. These are all generally steels which are popularly used in naval vessel. Okay, so there we use FSW at them. You can't imagine, and we got so good quality weld. Uma, if you go through my research article, there you will find actually in shipbuilding industry, whatever the different types of materials generally used, there we join this material by using friction stir welding process. And pulse ticked and MIG welding process also you can use. Definitely, you can use it. Ganeshan Rao, how do we define solid liquid welding process? Yeah, Ganeshan, solid liquid welding process generally, you see, depending upon the phases, welding is categorized in three different categories. I have already told you. One is called solid state welding. That is one of the example already Uma asked. That is friction stir welding. That is solid state. Another one is called liquid state welding. That means all fusion welding process is called generally you can say is called liquid state welding. Another one is called solid liquid state. What is solid liquid state? Here these things, because here generally the filler material is in liquid state, whereas the parent material is in solid state. What I am telling, understand? That means once something is in liquid state, that means in joining composition, actually joining composition, if something is in solid state and something is in liquid state, then what happens, these two phases are present, that is called solid liquid, like soldering, brazing, these are generally called solid liquid phase welding, because here the circuit board is in solid state, it is not melted, correct? But whatever the filler material you are using to connect this circuit board, connect with circuit board with some resistance or other things, that thing generally what is called that filler wire, whatever the filler wire you are using, that filler wire is in liquid state. So circuit board in this joint, circuit board is in solid, circuit board is also in a part of that joint. So in this joint, one part which is in solid state, which is not melting at all, whereas the filler wire which is generally using in this joining region, that is in liquid state. That's why these types of welding process is called solid liquid state welding process. Okay. Yes. Qasim, yeah, Qasim, you have asked a question. Sir, can you share your mail ID? Yeah, I'll definitely, here I am writing my mail ID. Biswas. Explains her solid state and example. Solid state welding means is a friction stir welding is a solid state welding process. What is solid state welding process? Solid state means here the material does not melt. That means whatever the parent material, whatever the material you are going to join, that material temperature does not go beyond its melting point temperature. Like in friction stir welding process, here the material temperature is within a range of what it's called, within a range of what, how much? Within a range of only 80% of melting point temperature. Okay, what I am telling, understand? 80% of melting point temperature. That's why you see this is generally called solid state welding process. Why it is called solid state welding process? Because here the material does not goes beyond its melting point temperature. Okay. 1 minute. I think already time is okay. No problem. Let's. I think another 1-2 questions are there. It will be better. I'll explain some another 1 questions. Sir, can I get some information in details? Sir, can I mail you for some more? Definitely, Uma. Anytime you are welcome to discuss about your problem. Anytime you can call me. Anytime actually, you are always welcome, Uma. Okay. Any other questions are there or not? Let's see after that. I think no more questions are available. That's why. Hello. Hello. Uh, I think time is up. Hello. Madam. Okay. Can I carry on? Actually, their question also completed. Okay. Whatever the question they ask, actually no more question are available. I have asked most. I have discussed most of the questions actually. So some question were there. I told them to contact with me in my mail. So, madam, can we leave? Yeah, I think no more question are there. They asked me to give my mail ID. I have already provided them my mail ID.